Well, hello, and welcome to a new video talking about object-oriented programming using Java. Today we're going to talk about classes and relationship between classes. We're going to talk about composition, aggregation, and association. We're also going to talk about inheritance. We're going to see what is the meaning of all these terminology. And I just should let you know from now that those terminologies, those terms are extremely important in the world of object-oriented programming, and usually you'll be asked about them in interviews because they really get a lot of people confused when they try to understand what is the concept and what's the difference between them. So today we're going to talk about all these concepts, and we're going to demonstrate them, show you how do they work. Also, today we're going to talk about method chaining, date class. We're going to talk about overload versus override. And we're going to talk about this keyword and super keyword. And then at the end, we're going to talk about an example. In the previous video, I talked about, I showed you the demonstration of how do we create a patient registry class. And I'm not really impressed with that example. So today I have another one, a lot more complicated. And it's more related to real life applications, which is basically a hospital system. And I'm going to show you the UML and how does it look like and the relationship between all the classes and objects we're going to create. So let's get this party started. The first thing I'm going to talk about is method chaining. Now, method chaining, again, it's not a really big deal. You can use it if you want. You don't have to use it, don't use it, but it's a good idea to understand because you'll see a lot of classes or a lot of code will be given to you, and those projects basically involve or contain a method chaining. So it's important to understand what is a method chaining. And I'm going to use an example to explain what is method chaining, and also I'm going to use the same example to talk about the date class. So let's move on here. And I am just going to show you an example here, and then I'm going to go to the Eclipse and demonstrate it. So in any class, for example, imagine that we have a class called point, and this point class has two private data types, which is integer x and integer y. Now, those two methods that you see here are tradition setters, where we try to set the value of x and set the value of y. Well, let me just start with this. Method chaining is not only associated with setters. You can use it with any other methods that you have in your class, but we usually use them with setters. So that would be number one to talk about. So this is, again, how the setters, and that was my phone, by the way. This is basically how the setters look like. Now, if I convert them to method chaining and include method chaining, what am I supposed to do? Well, basically, I need to change. All I have to do is just change the return data type to return an object from the same class. So since the class is called point, then the return data type is going to be point, as you can see here. That will be number one. Number two, you need to have a return statement since it's not void anymore. It's going to return an object, and the object that's going to be returning is basically this, the same object that we're talking about. Same thing here with the set y. So you can see here, updating or changing your class, it's not a big deal. It's very simple and straightforward. Now, how do I use it? Well, the idea is very simple. If you are using those setters inside your class, inside the point class, for example, this is how the method chaining looks. And I can see here, this dot set x, and you want to set it with 10, dot set y. And as you can see here, method chaining basically means I can call multiple methods, separate them with the period here. And this is basically called a chain of methods. And that's what method chaining is all about. Now here, the outside, if I want to go and use it outside of the class, remember they're public, then all you have to do, for example, I'm creating a new object of point, I'm calling it point1 or p1, new point, and here it is, dot set x dot set y. And this is basically what method chaining is all about. Now you may ask the question, what is the point of method chaining? Well, method chaining basically improves the readability of your code. What does that mean? For example, if I'm not using method chaining, and let me just go ahead and show you that. This here is my point class. Where is it? Let me just go at the top. Yes. So you can see here I got X and Y. For now, I just want you to ignore this part. Just let's focus on the X and the Y here. So private X, private Y. And you can see here, this is set X, this set Y. And then here we go, this set X, this set Y. And this is the tradition way. Well, after that, I do have a constructors, and then I have two string methods, and then after that I have get X, get Y, get date, which we're going to talk about later. And here I have set X and set Y. You can see here it's a void and a void. Now, if I want to convert this to be a method chaining, this is how we do it. We just come here and say this is going to be a point object, same thing here, point object, and then after that return this, just like we did before. Same thing here, return this. Sorry, semicolon here. Okay, now we go back here at the top, and instead of actually calling those two methods in two separate lines, I can call them in a single line, like that. And you just have to make sure that there's a period between them. And in the default constructor, I'm basically going to set them all to zeros, and here I'm going to set them with whatever arguments are passed to them. So those are basically what we mean by method chaining. Now, if I go back to the main class, or the main method, and as you can see here, now I'm going to explain why I'm doing this later, but for now, this is a point, P1, excuse me, and this is basically calling the default constructor, and this is me creating another point, P2, and I got 10 and 20. Now, I want you to pay attention. If you look at this class, you need to be familiar with what is a point, and you're going to try to guess, oh, since it's a point, it has an X and a Y value, so this is X, this is Y. But again, remember, you're guessing here. Imagine you don't have access to the point class, so you're basically making a guess here. Well, here's how method chaining will clear things for the people who are going to use those methods. Set X equal 10, and then dot set Y equal 20. So again, now I know that X is going to be used to set a variable called X, and now I know that 20 is going to be used to set a variable called Y. That's basically what method chaining is. So it's not a really big deal, but again, if you're going to be working on a project of other people, you probably will see it a lot, because the main attention here for those setters using method chaining is basically to give you an idea about what's going on and how does it work. Another one, basically, if you have multiple steps that the result of the next step depends on the result of the previous step, you can put those in a method chaining format as well. Well, that's basically what method chaining is all about. It's very simple, it's good, it's very straightforward. Now let's talk about the date class. And you can see here that I created a date object here. This is a form of association, which I'm going to be talking about later. But for now, just to give you an idea, what is date? Let's just look at the date by itself. Date is not a primitive data type. It's not an integer. It's not a double. It's not a Boolean. It's not a character. It's basically an object. So association, aggregation, composition, all together means they mean basically you can have an object of another class declared as a member of your current class. And that's a type of relationship between classes that we have. So I have a class called point, and there's another class called date, and a date object, which is basically point date here, is a member of the class point. Now, what type of relationship is this? Well, it's association for now, and then after that we can define it if it's going to be composition or is it going to be aggregation. And that's what I want to talk about right now. I'm going to talk about that with a lot of more details in a sec. Now, since I'm using another class, and that class, if you look here, this is my project here, method chaining, you don't see the date class defined here. So basically, it doesn't exist as a part of my class. So for that reason, I need to import it, and this is where we import it. Now, do I have to memorize this? Kind of, yes. This is basically how it works with Java. Every time you want to import or use a class that has been predefined by some other people, basically I'm talking about the standard library here, you need to know how do you import it. So you're going to import Java, which is the big class, and inside it there's a class called util, and inside the util there's a class called date. Is that the only classes that we have for dates? No, we have local date, we have local time, we have another two classes, which basically you just need to Google it, and I think the Schooler W3 will give you a lot of more details about that if you go do a search. For now, I'm just going to use the date one. It's a very simple one. Now, in this area, this is important to understand the syntax whenever you want to do something like that. You created it's a private again, it's a data type date, just like the integer here, it's a date, and this is the name that you gave it. Now, inside the constructor where you're basically going to create an object, you need to define what will be the value of this point date. And since it's an object that belongs to another class, this is how we do it. We don't come here and just set it with a value. We don't know what is the value. We have to call the constructor. And in this case, I'm calling the default constructor here. And the default constructor for this specific class basically will set the data point to the date and the time where this object when this object was created. This is very important to understand. And it has an argument constructor, as you can see, a default constructor. Now the same thing here is applied with the argument constructor. Again, I'm not going to pass anything here. I'm just going to, at the moment that I'm going to create this point, I want to know what is the month, what is the day, what is the year, and what is the time exactly. Now, if you want to process the data, I will recommend to go and use the local data and local time, which again, I want you to go ahead and read about it by yourself. So here we go. This is the toString method, and as you can see here, I'm putting X, I'm putting Y in the form of two values surrounded with the parentheses, and then the next line is going to be the date of creation, and then I'm going to put the date. Let me just put this here so it will not look different. This dot point date. And it's going to return that string. We talked about toString method before. These are the getters and these are the setters. Now I'm going to go ahead and run it. I already run it, but let's just give it a try again. And here we go. So this is the first point that I created. And then after that, because Java will work really, really fast, you will notice that if I take this two lines away, you will have the same exact time and date for both points. So I wanted to have some time between the creation for those 2 points. So what I did here, I created a very, very long for loop. As you can see here, for x equals 0, as long as x is less than this number, I'm going to update the temp. I'm trying to call a method or do some operation here just to waste time. So you will see the difference between the time that this object was created and this object was created. After that, I printed those two objects, and you can see here, object of 00 with the default constructor was created on Friday, June 12, 10:36 and 1 second, EST 2020. And the second object was created again. You can see that it's exactly the same time and same everything, except that we have 3 seconds different, 2 seconds different. So basically, the time it takes for this for loop to finish the process, even though I'm not showing anything on the screen, which if I do, it will take really, really long time. 2 seconds is out between them. Let's start talking about association and aggregation and composition. Now, what are those 3 terms and what do they mean? Well, let me go back to the project that I just created, and let me show you an example here. This here is a class called point, which I just created, and now you can see here I got a primitive data type of integer, and I called it x and y. So those are data members. Now I want you to pay attention to this member here. What is this member? It's a private, and what is the type of this member? It's a date, and it's called point date. Now, what did I just do here? Basically, I included an object, and I called it point date, that belonged to a class called date. And here I am importing that class. So association basically means, it basically means like when you actually have a member in your class which is an object of another class. And that's basically what we mean by association. So instead of having primitive data types, as you can see here, now I can have member, but this time this member here is an object that belongs to another class, and that's basically what we mean by association. Now, the relationship between those 2 classes, which I'm going to show you in a sec, how do we represent this relationship? I'm going to go and show you examples later, but let's go back here and talk about association. Basically, the relationship here between this owner and this pet here is what we call an association, because this owner has a pet, and this pet has an owner. And this is what we call a bidirectional relationship, because the owner as an object for a class called owner can have a pet as an object, and the pet as an object that belongs to a class called pet could have the owner as a member. So it goes both ways. Like I can have two objects, one of them a person male and another person female. A person male is married to the female, and the female is married to the male. You see there, the relationship between them goes both ways. Sometimes, no, it goes one direction. You cannot say, I have a phone, for example, but you cannot tell that a phone has me. Well, actually, you can tell that if you want to consider the owner of the phone as an object. Yeah, that's possible. But as we go back to this example, sometimes it's two directions, sometimes it's a unidirection. Now, that's basically what we call that's basically what we mean by association. Now, association by itself could be divided, could be an aggregation, or it could be a composition. How do I know which one of them is which? Well, basically, composition means when you create a relationship between two objects, and when you destroy one of the object, the two classes that you have in composition, one of them is going to be the parent, and the other one is going to be the child. That's very important to understand. For example, let's say, have a head. So I can have a class called head and a class called person, and the person has a head. This is what we call composition. Now, when that person is destroyed, the head will be destroyed with him. Whenever you get a case like that, that's basically what we mean by composition. When you destroy, or when the parent is destroyed, basically the child will be destroyed as well. And that's the relationship between the parent class and the child class, and basically that's a composition case. Again, as I said, when you destroy the parent, the child will be destroyed as well. Now, what is aggregation? Well, basically, aggregation doesn't mean necessarily when you destroy the parent, the child will be destroyed. That's not the case. Let me just go back to my example to tell you what does that mean. If I go back here, now you see here this date point here. Now imagine I am gonna come here, and let's imagine in this constructor here, at this point constructor, and this argument constructor, I can actually pass the date as an object, and I add it here in this area here. So a point in the argument constructor will be defined by the value of x and the value of y and the object of date that's going to be passed to it. So let me just do it here really quick. I'm going to copy this. I'm going to come down here, and I'm going to come here in this area, and I'm going to pass date, and I'll call it D. And then in this area here, instead of assigning to a new date, it's basically going to be assigned to D. Whatever D is going to be assigned to date point. So you can see here, I got a 3-argument constructor. Now, let's go back here, and let me create a new date. Where is it? Here. I'm going to come here at the bottom and say date, let's call it my date, equal new date, and let's keep it this way. Now, of course, he's complaining you have to import it. I know I imported it here, but again, you have to import it here as well. So import it with util. Okay? So here we go. I got my date created. Now what I'm going to do, I'm going to create a new point. So point, and I'll call it P3, for example, equal new point. And I'm going to pass, let's say, this is very important, I'm going to pass 3, 8, and my date. So this is basically me creating this new object of point, and I'm passing the date that I created here. Okay, now this is, imagine, and I want you to imagine that I have another class. I'm not going to create that class for now because I don't want to make this video to be very long, but just imagine there's another class, and this class is called, for example, zombie. Okay, just think about it as zombie. And what I did basically, I also have in the zombie class a data member. Okay, and in the constructor of that zombie, I actually passed the same date that I passed to point 3. So basically, you can see here the relationship is going on. I have an object of point and I have another object of a zombie, and both of them are having the same object as a data member, which is my date. Now, destroying point object P3 will not necessarily lead to destroying my date, because my date is basically used by another object that belongs to another class. And this is basically what we mean by aggregation. So that's, again, the relationship between them. Just remember, whenever you have two classes and there's a relationship between them, could be a unidirectional, could be bidirectional, and one of them is going to be a child, and the other is going to be a parent, and we describe association as an object has a data member, which is an object of another class, which basically means, let's call this lady Susan. Susan is an honor. That basically means she belonged to an honor class, and she has a pet. Let's call this one, I don't know what they call dogs. So let's just call it P. Susan has a P as a pet. So Susan has. And again, P, the dog itself, has Susan as an owner. So you see the relationship between them with association. Now, when it comes to the relationship between them and the lifetime of this object, we got composition and we got aggregation. Composition basically means destroying the parent. If destroying the parent will lead to destroying the child, that's a composition. Again, take this example. I have a head. If I'm destroyed, my head, of course, is going to be destroyed with me. That's basically what we mean by composition. But again, aggregation doesn't necessarily mean that destroying the parent will lead to destroying the child. And I do have an example here to show you the meaning of this. For example, this is a person, he has a head, hand, and leg. Destroying this person leads to destroying all the other objects that belong to that class. Now we have a car. If you look at this car has wheels and it has engine, and you can see here the engine basically, there's an engine, I don't know, what is this, fiction? I don't know what's that. Well, engine lines, whatever it is. I can't read, I don't wear my glasses now. So this object basically has an engine. This car has an engine. Now, destroying the car or destroying this object would not necessarily mean that the engine was destroyed with it. Same thing with the wheels. The car could be in a car accident, but the wheels still usable. So that's basically what I mean by aggregation. You can read this aggregation. The aggregation stresses the point that a class A instance, which means object, is not exclusive container of class B. Basically, that's what I mean by here. Engine here doesn't mean the car is not the exclusive container of the engine. Basically, there's another class that could actually contain engine as well. Now, one last thing I want to talk about before I move to inheritance is how do I represent the relationship between these classes using UML? As you can see here, the relationship between those classes is presented with this line here and this diamond, black diamond here. That's basically when we have a composition. And this basically to give whoever's reading UML an idea that destroying the person will lead to destroying all of those. Now, when you have a white diamond, basically means this is aggregation. Now, if you don't have any diamonds, you just have a line that goes from one class to the other, that's association, and you just can decide how many, for example, how many heads a person can have. You can write the number here, and how many persons a head can have, which basically doesn't make any sense in this case. But if we replace this one with a teacher and a student, you can say how many teachers a student has. That will work. Could be one, could be more. And how many students a teacher has could be one, it could be more. This will be the end of the relationship between the first type of relationship, association, aggregation, and composition. And then after that, we're going to move on and talk about inheritance. Okay, so let's start talking about inheritance right now. The concept of inheritance is really, really simple and not that complicated. Let me just let you know also that the concept of composition, association, aggregation is still not that complicated. The idea here, if I want to simplify it, is just basically, if you have a class, you can create an object of another class as a member of that class. That's basically a simple definition of association. And again, after that, you can categorize that association as a composition or aggregation. It depends on how do you look at the lifetime of those objects after you created them. So let's just put that on the side. Let's talk about inheritance. What is inheritance? Well, inheritance basically means creating a new class using a class that already exists. That's basically what inheritance is. And in those two examples that you see here, I do have a graphical representation of inheritance. For example, I can have a class called animal, and I can have 4 other classes or 3 other classes, dogs, cats, and cows. And in the class of animal, basically, I will define what an animal would do. And then after that, since dog is an animal, and cat is an animal, and the cow is an animal, so basically they will be doing whatever the animal will be doing: breathing, eating, jumping, moving, making sounds, making noises. So this is basically what we mean by that. So instead of me repeating all those attributes, variables, methods for each one of those classes individually, and you will notice that you'll be mostly repeating the same thing here and here and here. So why would I want to do that? Well, basically, I could put them all under one class called an animal and let them all inherit. So that will save me some the size of the code. It makes more sense to do it that way. Now, here's another example. We have an electronic item, which basically will be inherited by a phone and a speaker. Think about it as an integrated circuit. And then from the phone, I can have another 2 classes, a mobile phone and a cord phone. I don't know if any of you guys remember cord phones. So those 2 phones are going to be inheriting from a phone class. The same thing here. We can use earplugs, and you can have stereos, and they're all going to inherit from a sound system. So the idea here again is very simple: creating class from a class that hasn't been already created. This basically again will make the process of creating objects using object-oriented programming, it's a lot easier. So what I'm going to do, I'm going to go back to my example, the point example. As you can see here, this is my point example. And I want to create a circle example. Now think about this. What is a circle? If you want to compare it to a point, well, a circle is a point. It's a center point that has a radius. That's basically what a circle is. So what I can do, I can copy whatever I have here and paste them here, and just add the radius to it. So just go ahead. I don't want to do it now. I don't want to put it on delete. So basically, that's what I mean here. I can create circle, and instead of repeating most of this code again here and adding a little bit more to it, I can use the point as a part of the circle class without the need to repeat the code. And the idea here is very simple. You have to come here and type extend. And I don't think I extend. No. Let me just. Oh my God! What is the spelling of extend? Let me just Google that. OP Java extend. I'm just trying to remember the syntax. Here it is. Extend. What did I type then? Vehicle extends. Oh, the S. Okay. Here we go. So I didn't type extends. Okay, well, I'll just do it again. Okay, now we're going to extend what? Point. And here we go. So this is me. This is basically just typing this here. It's not exactly 100%, but it's like equivalent to copying this and pasting it here. Now, there are certain rules that we have to understand whenever we want to do that. Rule number 1. Those are private data types. You don't have access to them directly here. You cannot come inside the circle class and try to change X and Y directly. If you want to do that, you have to use the setters. That's rule that you have to follow. So anytime you extend from a class, you should know that you don't have direct access to its private data types. If you don't have access to them, the only chance you have here is to basically going through the setters and the getters. With that being said, that again, this is a very simple rule, as you can see here. And let me tell you something. OOP in Java, it's a lot easier than C++ OOP. Let's just put it that way. So what do I want to add here? I want to add a double private. What is wrong with me today? What is private? Here it is. What did I type? Oh. Private. Yes. Finally. I'll go double radius. And that's it. That's pretty much what I want to do here. Just add a private radius. What do we want to do also here? Well, we want to calculate the area here. So I will say, oh, I want to have the constructor. I forgot about that. So let's copy this constructor, put it here, and it's going to be public. Let me just, I always like to put a divider between the private. So public circle, and I'll go with a default. Now I think you may be asking yourself, well, how about the constructor of the circle and of the point here, the default one, the argument one? What am I supposed to do here? Well, let's just go ahead and put a radius, and let's set it to 0. Oh, you know what? Since I'm going to have a setter, let's just go ahead and use it. Before I do anything, let me take this away. I'm going to go ahead and do the setters and the getters here. So source, getters and setters. There was a time where I used to do both of them together. So generate, that's the getter. And let's go ahead and do the setter. Come on. Setter. Generate. The return is easy, the get, but this one I'm basically going to have to put some if statement here. If radius is less than 0, basically negative value, I'll just set it to 1 because that's not acceptable. So radius, this radius, I'm going to set it to Control-C, set it to 1. Otherwise, set it to whatever you passed. So I just want to make sure that the user, for example, will not pass a negative value to be assigned to the radius. And let's just put 0.0 as an indication that this is a double. Okay, so here we go. This is it. So I'm going to come here and say radius this dot set so radius, and I'll just pass 1. And let me create another one. This time I'm going to pass an argument, so double radius, and we'll just pass radius here. Control-C, I'll put it here. Okay, now the question that you have to ask. Now we're going to get into a little bit of details about those two circles. Now, since I am going to extend this, what do you call it, the class point into the class circle, when I'm going to create, let's say, a circle object in this area, what just happened here? Okay, when I'm going to come here and create a circle object, what's going to happen, since I'm extending the point object here, what's going to happen to the default constructors and the constructors of the point? Well, let me just put it here as a rule. Whenever you create a circle object, and circle object is extending another object, which is another class, which is basically a point here, the default constructor of the point is going to be called. So what does that mean? And before I tell you what does that mean, let's come here and do one thing too. Since toString is inherited as well from here, I need to add to it because it's going to be inherited as where is it? Point toString. Here it is. So it's just basically going to show me the x and the y of the value and the date where it was created, but it's not going to show me the radius, for example. So I need to show the radius. What I'm going to come here and do this. This is extremely important. Public string, and then the function called toString, and it's uppercase S, of course. Now, let me just open this, close that, and this. Okay, why are you complaining? Because you must return. I am, of course. I'm going to come here and type str. Let's change it. String my str, just for it to look different, and I will say the radius is, and I'm going to put a plus this dot get radius. And then after that, let's just go back here and type return my str. Okay, so this is just basically so I can show you the results. Now, there's a lot of details that I need to talk about here, and I'm going to go through them one by one. But let's talk about the constructors now. I'm going to come here and do this. Circle. Circle. Let me save it. And I'll call this one C. Well, did I misspell it again? C1 equal new circle. And I'm just going to pass and call the default constructor. And I'm going to come here and say C1 dot, system dot out dot print line. And I'll pass C1 here and put semicolon. So that's my first circle. Now let's create another circle, but this time I am going to pass a value here. We'll put, for example, 12.897. And let's just call it C2, of course. And I'll go ahead and do C2 as well. Now, I'm going to run it, and I want you to pay attention to, let me ask the question first. What will be the value, since I'm creating circles, and we know a circle should have a central point, what will be the central point for C1 and for C2? I already answered that question, but I'm just going to run it so you'll see it yourself. And here it is. Look at this. C1 is this, and the C2, this is where it's created, but again, it's not showing me the string method. This is not working. Basically, what's working is the previous one, and that's not what I want. I need this. Yeah, okay, I see what's going on here. I'm going to talk about that in a sec, but just let's just focus on the point part here. As you can see here, it's showing me the points as the default constructor. Now the question is, what if I don't want that to happen? What if I want to call, and let me show you, what if I want to call this constructor? Oh, not this one, sorry. I'm talking about the points here. What if I want to call this constructor here, with the one with two x's? Okay, well, that's possible, but here's what you need to do. And let's go ahead and do that really, really quick. In the circle, I'm going to have a new constructor. This time, I'm going to put an integer x, integer y, and here we go. Now, even though I'm passing x and y, but that will not change anything, and this is basically what we need to do. You type super, and you put x, and you put y here. So, what is the super keyword? Well, every time you want to call any method, should be public, by the way, a public method from, let me just go back to this. I forgot to mention that. Whenever you have an extend classes, this is basically called the superclass, and this is called a subclass.
My bad. This is the subclass and this is the superclass. The one that you inherit from is the super, and the one that's inheriting is the sub. So this is subclass, this is superclass. So when I came, where is it here? When I wanted to call the argument constructor of the superclass, just type the keyword super and pass those two. So basically x and y are going to be passed to here, and there's going to be used to set those values. Let's go ahead and give this a try. Now I know there's something about this toString that I need to fix, but I'm just going to wait for a sec. Just remember, this is the keyword that I'm talking about here, the super keyword. Okay, let's go ahead and create a new object. I'm going to copy this. I'm going to come here and put C3 this time. And here I'm going to put 10 and 20 and 12. Let's put here 111. That's a really big. Let's make it a little bit smaller. I'll put 6, for example. Let's run it. Now I want you to pay. Oops. Why are you complaining? Of course, because this column here. And oh, look at this. Still doing the same thing. Oh, of course, C3. Oh, here it is. Okay, so now it works perfect fine. Still, I have an issue with that toString methods. It's basically, I'm inheriting, look at this. I'm inheriting the toString method. Let me just go back here and check to make sure that I didn't misspell anything. toString, what did I call this one? Here it is. This toString. Okay, that makes perfect sense. Oh, lowercase t. Okay, now let me just explain what I just did here. In your subclass, if you want to call a method from the superclass, you just want to involve it. Basically, you want to call the default constructor. In this case, you call super. You put x and y, so you call the default constructor. Sorry, the argument constructor, as you can see here. And now, this is basically where you use the super keyword. I want you to pay attention here. Whenever you have inheritance relationship and there's a method inside the superclass, you want to use it. Then you basically use the keyword super to be able to use that method here. Even you have access to it, and that's basically how you have access to it, by calling the super method inside it, of course. Now, I want you to pay attention to this. This is extremely important. If I run it again, remember here, I changed this toString, and look what's going to happen if I run it. Oh, it's basically just showing me the radius. Okay, but again, I do have the toString here that I inherited. Now, so what's going on here? I have a class called toString inside my point class. I inherited it to my class, but inside my subclass, I also have a method that is exactly the same. Public, string, string, toString, toString. No arguments, no arguments. This is a case where we call overriding. Overriding basically means, this is very important to understand this concept, overriding basically means when you inherit a method from a superclass and you don't like, or the way that method is implemented in the superclass doesn't serve the purpose of the new class you created. That's basically what we mean. You rewrite the method again, and that basically means we'll cancel the original method that I inherited. In this case, this is basically what I have here. I override the toString, so it's going to show me the radius. But now you may ask the question, well, I still want to see the x and the y and the date of creation. Well, I will tell you this is simple. If you come here and do this, look at this. Super dot toString. I put semicolon here. Now let me run it. Oops, that didn't work too. Let's see here. Why is that? I knew it. That's not going to work. There should be a way that I can actually call this method here, but I don't have that object. Well, yeah, this is not going to work here. If I want to see the results of those, basically I need to have access to them just like I did here. Now look what I'm going to do. If I come here and copy this, it's not going to work. Let me just show you. Copy that. I'm going to put it here. And I'm going to come here and put, look at this, plus backslash n. Now, as you can see here, he's complaining about the x and the y and the z. Why is he complaining about them? Because again, they're private. You don't have access to them. You cannot have access to them here. So what we can do, you can actually change this to be get x and change this to be get y, and this is why basically you need to have the get and y. And of course, here you need to get my point. Get point, and you have to put, of course, the parentheses. Now, the return statement, basically, I'm going to put str plus my string, so both of them are going to be returned, and that's basically will fix the problem. So if I run it again, I hope this time, yep, and here it is, 0, 0, date of creation, and the radius. The second one, same thing, was 0, 0, date of creation, radius, and the third one is the 10 and the radius. Let's see here. Oh, I got the radius here, but I'm calling the default constructor as well here. And this one, no, I'm actually assigning values for x and y. So what did I just mention here in this lecture? Well, basically, we talked about the super keyword, as you can see here. I talked about overriding, as you can see here. And we talked about this keyword before, and it's very important to understand the concept of using this keyword. Just to give you an idea, what do we mean by this? I'll tell you what we mean by this. Let's go back here. You see C1 here? When I created C1, when you go back to your circle Java, C1 has a radius. So when I have access to that radius, basically this here is talking about C1. When I get to this point, C2, now when I go back here, there's another this keyword, and this keyword this time is basically indicating the C2 object. So every single object is presented inside the class using the term this. That would be something to understand. Now the superclass, again, as you can see here, I was trying to have access to the constructor here. And where is it? The argument constructor. So I use the keyword this. Also, you can have access to any method here if I want. Where is it? Although those are public data, so you can have access to them directly with no need to use the keyboard, the super. Now, let me just show you an example about how important it is those functions here, the get or the setters. As you can see here, I was able to use them inside this method here, and I can come here and say C3, for example, dot set x and change it if I want, and still that will work. For example, I'll put 120. I can do that. Why? Because set x is a public method and it's inherited by the circle C3. And that's pretty much it. Now let's just gonna go ahead and add a little bit. So we got the circle, circle, circle. We have the getter, we have the setter, we have the two strings. Well, let's just calculate the area, for example. So double, and it's going to be public. And I'll just go ahead and call it area. And how do we calculate the area? Well, we'll create a double variable. I will call it A equal. Well, we have the pi. So how do I have access to the pi? It's pi multiplied by the radius to the power of 2. Well, here it is. This is a good example, actually. If I type math.pi, that should work. No, pi uppercase multiplied by, yep, it's work. I think it's working. And what do I multiply? Well, I multiplied by power, pw, and you have to type math, I think, here again. pw, and here we want the radius, so this dot get radius. So get the radius to the power of 2 and put semicolon. Is he going to complain? Yep, I got that right with no problems. You can see here the math here is used. Those are static methods. And then return A, semicolon. There's a math class that I will recommend everybody to go and have a look at it. Those are two functions, or this is a variable that I use with code, which is pi, and this is the power, so it's going to be the radius to the power of 2, and that will give me the radius. Well, let me just try to remember. Is that what it is? 2 pi? Yeah, that's how you calculate the area of a circle. 2 pi r is, okay, that's not the radius. Okay, now if I go back here, and let's go back here, and I can come here and just say system.out.print line, and I'll just come here and say c3.area. And put semicolon. Let's give this a try. And here it is. It's way too big. Well, since we're here, let me show you something here. I will put printf, and I will put double quotation, question mark, and I'll put 0.2f. If I want to, let's make it 3. This is a print format. And print format, basically, I think I explained that before. Here it is. Oops. No. I need to put percent. I forgot the percent. Oh, no. Why he doesn't like it. Print format. I think it's print. That's basic public compile. No. It's supposed to be F. Why is he complaining? Misformatting. You know what? I'll talk about that later. I'll just go and do a little bit of research because I forgot about how do we use it. Okay, so here we go. This is the print line to show you the area. Now, before I stop, now we talked about this and the super keyword. We talked about overriding. Let's talk about overloading, something that I didn't mention before. I mentioned it before, but let's just go ahead. You see this here? This is basically what we mean by overloading. Remember, there's overloading and there's overriding. Overriding, let's go back to overriding, when you have two methods between two classes, and one of them is inherited from the other, and the two methods are exactly the same. By the exact same, I'm talking about the signature, which is basically the head of the method. Return data type, specifier, and the name and the arguments. So public string, toString, no arguments. Where is it here? Public string, toString, no arguments. This is overriding. Overriding basically means when you inherit from a method, from a class, and the implementation doesn't deserve you, so you have to change it. That's basically what overriding means. Overloading is basically when you have multiple methods within the same class that has the same specifier, as you can see here, and it's not necessarily to have the same data type, return data type, that's okay, but what's very important here is this part, circle, circle, and circle. Three methods that share the same exact name, but they are different with what? Number of arguments and the type of arguments. This is overloading. Now, terminology here is important because guess what? In interviews, you'll ask about that. They check, do you see if you know the terminology first? After that, they get into the details. So this is overloading and this is overriding. Now, one last thing I want to talk about is why would I need to override a method? And let me go back to the example that I have here. If you look at those this animal class, and you have a dog, you have a cat, and you have a cow, imagine there's another animal here, which is a fish. Think about it. We have another animal here is a fish. Now, all of them, they inherit from that animal. Let's say they all eat, they all move, they all have colors, they all well, they don't drink all the time because the fishes, I don't know if fish drinks or not. But let me just focus on one. Breathe. All of them, they breathe. So the cat, the dog, and the cow, and the fish, all of them, they breathe. Now the question is, if I want to come here inside the animal class and define the breathe mechanism, well, you have the lungs, then you have the movements where the lungs goes down, and then the air goes inside, and then your lungs will get the oxygen, and then you push out the CO2. That's how you will think about breathing. And if you think about it, dogs and cats and cows, they breathe the same mechanism, but you cannot say the same thing about fishes. So if the fish is going to inherit from the animal, well, if we don't override that breathing method, basically that means the fish will have lungs and it's going to breathe out the other animals. And we know that this is not true. This is not how fishes breathe. So basically you need to override that breathing method for the fish so it can use the animal class with no problems. I'm going to stop at this point and I'm going to show you a real life example about inheritance and composition and association and polymorphism, and aggregation. And I'll leave it to you to decide if you want to actually do it. I will highly recommend for you to do it. It's a lot of work, but it's not complicated. So I'll be back in a sec.
The last part of this video is going to be about an example to show you the relationship between classes. Now, in this graph that you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different classes. And all these 16 different classes basically present a hospital system. Now, you may think, oh my God, this is so complicated, but in reality, it's not. It's the same concept. It's the same thing that you just learned. It's just going to be scaled out really, really big. So I'm just going to go through it. And again, I want you to think about this. This could be your project, the final project for this course. I don't mind if you want to use it. So as you can see here, we have a class called person. And inside the class of person, we do have a lot of attributes that describe that person. Title, given name, middle name, family name, full name, birth date, gender, home address, and phone. We do have another class called hospital, and the hospital has a string which represents the name and an address and a phone number for that hospital. Now, you see the relationship between them. This is basically association where you can say a hospital has a person and a person has a hospital. You have a hospital that you go to, and a hospital has a list of patients. Now, the asterisk you can see here, I don't know if you can see the mouse, this basically indicates that this person could have multiple hospitals that he visit, and this hospital could have multiple persons that come to be checked at this hospital. So this is the type of relationship that you understand from the symbol that were used here. Now, this is a patient and this is a staff. Now, as you can see here, the patient is inheriting from the staff. This arrow here telling me that this patient is inheriting from this person, and this staff is inheriting from the person. So basically, if you think about a patient and a staff, both of them are person. So that's another relationship that we're talking about. And again, inside the patient, you can see that we have ID, we have name, gender, birthday. I can see here, this basically means those three is duplicated from what we have here. So you're inheriting them. By typing in them here, it doesn't necessarily that you're going to write them again. It's just to tell you that this patient that has a name is going to be inherited from. You see the ID, you don't have it there because you didn't inherit an ID. But since you're inheriting those three, so basically you're going to put this arrow here to indicate that even though those variables do exist here, they are inherited from this person class. Same thing here. You got joint. I think that's where that staff joined the hospital, and the level of education, if he has certification, and the languages he can speak. So he's a person with all these extra attributes. Now, look at the relationship between these two here. Now, what did we say about this diamond? This diamond is aggregation. So we have a relationship here, an aggregation between the staff in the department, and the hospital. Now, look at this. This is a number one, and this is asterisk. That basically means, again, this hospital has departments or department. This asterisk basically means it could be one, it could be multiple. But this department is associated with what? With one hospital. And again, since I use a white diamond, that basically means aggregation. That basically means if the hospital was destroyed, the department not necessarily to be destroyed with it. Same thing here, you got the staff. Every single department have multiple staffs, and that's called the asterisk, and then every single staff belongs to a single department. And this is another aggregation relationship. Now, let's keep going, moving down here. When it comes to the staff, we have three classes that are going to inherit from the staff. We have the operations staff,
and we have the administrative staff, and we have the technical staff. They all inherit from the staff class. Now, you have a special relationship here between the operation and the staff, because we know the operation, the people who sit on the front, those are the people who deal with patients at the beginning, so there is this association between them. Now, after that, a doctor, basically, of course, he's another kind of person who's going to be dealing with patients, so doctor's going to be inheriting from the operating staff, and the nurse is going to be inheriting from the operating staff. Now, the administrative, basically the front desk staff and the reception staff, I don't know exactly. Again, this is just a way to, you can think about it differently. And the technical staff, we have technicians, we have technology specialists, and we have surgical technologists. Those surgical technologists, basically, those are the people who deal with the machines in the operation rooms. And then, of course, from the doctor, we're going to inherit, the surgeon is going to inherit from the doctor. So you can see here, this graph, by a look at it, I have a very basic idea about how a hospital system will work. Now, I want you to imagine I can give you a project that contains thousands of lines of code, and I ask you to understand the structure of this project. Now, you may need to spend hours checking the code to understand how all these objects and how these classes work together. But a simple graph like the one that you see on the screen can give you a really good idea about how the system works. Now, what I want you to do, I want you to consider this. It's not an assignment. I'm not going to grade you for that or going to judge you for that. But if you want to really practice, go ahead and do this. You know what? If you want to really practice, think about graphic user interface and how can you convert this system into a graphic user interface system. That'll be a really good project to practice on.